In section 9, we're looking at order of operations. So in the warm-up here, we're asked to compute the following computations. We've got 9 plus 11 times 9. And to do that, what we're going to do is follow order of operations, which we're going to start, generally speaking, with any parentheses that we've got. I do have some parentheses, but the way these are written right here indicates multiplication to me. The next thing I'm looking for, since I don't have any exponents, is I'm looking for any multiplication and division, and I'm generally going to do those together from left to right. So I've got 9 plus, and then 11 times 9 will give me 99. Put those together, and we end up getting 108. So that should be a nice little refresher from previous years of working with those order of operations. Number 2 is a little bit more challenging because of the fact that we have a fraction. Now, believe it or not, we do actually have parentheses. They're just not really written there. They're kind of in disguise. We have parentheses here in the numerator and then also in the denominator. So within those parentheses, we're going to follow order of operations again. At the numerator, the first thing I want to do is multiply 8 times 7 to give me 56. But again, we've got that negative there, so I'm going to write it as negative 56. And then I'm going to leave that 7 plus 8 for now. I can change that in just a minute. In my next step, I'm going to take 7 minus 56, which is going to give me negative 49. And then 7 plus 8 in the denominator gives me 15. That does not reduce as a fraction. We don't want to turn that to a decimal. The directions say write it as a reduced fraction, so we're good to go with that. So in this section, that's kind of the foundation of it. But what we're really looking at are these uniquely defined operations, things that we don't know what they are. And in fact, they're just kind of defining it for a particular set of problems. Now, the purpose of these problems is, let's face it, you guys are going to be taking the SAT when you're juniors. These types of questions we know will be on there. So we want to make sure that you're prepared, ready to go for those questions. So operations can be defined as algebraic expressions. And here's our first example of a uniquely or newly defined operation. We have this A and then this backwards E here, B, is given as this. So I'm going to highlight some things just to kind of pull those out. Anywhere I see an A, I'm going to put a little highlight. I'm going to do the same thing with B, but in a different color. So we're defining this operation as A backwards EB is A plus B times A. The example that we have down here uses 9 as A, and B is 11. So we're just using this information right here, the fact that A falls before that backwards E, 9 has to be A. So we plug that into the formula and find out that our value is 108 using order of operations. Same problem we did on the warm-up. Looking at number 2, we've got a slightly different function or operation being defined. X and then the 3 dots there, Y. And the way we're going to define that is if we have an X, highlight those guys out, and then we have Y. This operation is defined as x minus y times x, all divided by x plus y. So looking down at our worked out example with numbers, 7 represents x. You'll notice those green highlights match up. And the same with the blue, we've got 8 represents the y. Again, use order of operations, simplify it, and we end up getting negative 49 over 15. So as a couple examples here, we have this third chunk here. We have C, and that looks like, I think, kappa, D, which is defined as this. So just like we did before, I'm going to just grab some letters here. C is right there. And then we've got D as one of our other variables. And that's right there. So anywhere I see C, I'm going to replace it, whatever that number happens to be, with that number. And then the D number will go in wherever D is. So looking at our problems down here, we have these 4 problems that involve this new operation. Actually, let's just look at the first 3. And the number before K will represent our C value. So I'm going to highlight those first. There's one of our values. There's another and another. Those are all C values. And then we have D values, the number after K. So my next step is to set up my expression using those numbers, and then to simplify it. So we use purple here for the c. So according to this, I'm going to start off with -2, and then times d, which is 3, and then -2. D was what, 3? Yes. Oops. And that didn't change colors for some reason. Let's make that work better. There we go. 3. And then we're going to do plus 3 times c, which is -2. So plus 3, and then times -2. All right, so we've got that all set up. And again, that is this expression right here, rewritten with the -2 and 3 plugged in. So following order of operations, looks like we got a bunch of multiplication going on here. So I'm going to multiply -2 times 3 right here, and I'm going to get -6. And apparently I'm going to do it again. It's a plus. And, I guess I'm going to do it again. 3 times -2 this time. Just coincidentally, those three numbers are exactly the same thing. It's not always going to work out that way. So when I put these together, -6, -6, and -6, I get -18. If we look at number 4, same operation, different numbers though. So we have a 6 and a 4 this time that we're going to plug into this formula. Let's see. So we're going to start with 6. And then we've got 4 minus 2 times d, which is 4, plus 3 times c, which is 6. And we are going to simplify. So 6 times 4, that's going to give me 24. -2 times 4 is going to give me -8, and 3 times 6 is going to give me 18. So when I put those together, I'll get 34. So notice again that those three terms are not the same here. They were the same here. That was just a happy coincidence. We've also got operations that we can use. Again, these are defined. They're going to be given to us. They're going to tell us what this operation is. You're never going to see a 6 and then that circle thing with a 2 without us telling you what that operation actually represents. So up top here we have the definition of that function, that operation. And then we're going to, let's see, highlight, let's go with orange, the z's. So we have the a's and the z's. Once again, we're going to look at our operation. We're going to pick out those numbers. A is the number in front of that circle thingamabobber. And so the other number is our z number. So when I'm setting this up, I'm going to take 9, and a is the next thing I plug in. In that case, it's 6. And then -6 times z. Z is 2. And then all of that is divided by z, which again we said was 2. And then plus a, which is 6. And -1. All right, so we're going to simplify it. Now, I'm going to show you a way to do that in the calculator. It makes it, I think, a pretty cool little trick the calculator can do. We can get into order operations. We can do the step-by-step. Okay, great. The calculator can do a lot of that for us if we know how to use it. So when we go to our calculator, the first thing I'm going to look for is how do I set up a fraction in that. There is no fraction button, but our calculator is definitely capable of doing fractions. So the first thing we're going to do is go to the Math menu. And when you're in the Math menu, there's actually a couple ways that you can do a fraction. One way is under here. I don't like that way. We've figured out that there's another menu. If you have the TI-84CE, we have this fraction menu. And notice that the first one says n over d. So n over d means numerator over denominator. If I go ahead and hit enter, you'll notice that it sets up a fraction for me. I'm just going to put in there exactly what I see. 9 times 6 minus 6
times 2. I'm going to arrow down to get to the denominator, so I press that arrow to get there. 2 plus 6 minus 1. And when I hit enter, if it's a fraction that needs to be reduced, it will do that for me. So, and of course we are off the screen, so let's make that work. There we go. Our final answer then would be 6. So again, not any different really from 3, 4, and 5, just that we have a different operation. So when we have this operation defined, we have to use this function formula for it. So that's how we're going to look at order of operations. Again, these newly defined operations, we will tell you what they represent. There's no memorization involved with this.